Now sometimes when observing scripts, you're going to come across this piece of code at the bottom of a script which says dunder name dunder is equal to or the same as the string dunder main dunder. So what does this mean and how can it help you? Well, first of all, the condition if dunder name dunder is the same as dunder main dunder is actually used in Python programming to execute the code inside of the if statement when the program is executed directly by the Python interpreter. Now alternatively, when you import a file as a module, the code inside the if statement is not executed. Now this may not be so clear as of now, but let me take you through the logic step by step so you understand what this if statement achieves. Now firstly, in Python, dunder name dunder represents what we call a special variable. Now there are many special variables in Python that start and end with double underscores, and because they start and end with double underscores, they are referred to as dunder, so it's easier to pronounce. Now inside this Jupyter notebook, if I were to simply print out what is referenced when I put dunder name dunder, which is a built-in variable name, you can see that the value comes back as dunder main dunder. And this is because I'm executing the code from within the file itself, in this case the file called modules and packages. Now how does this differ to when I import a Python module and then access the dunder name dunder variable? If I, for example, import the math module and then print out math.dunder name dunder, you can see that the value associated with the dunder name dunder variable is math, in other words, the name of the module. So let's pause there. When we call upon dunder name dunder inside the file we're working within, we bring back dunder main dunder. When we import the math module and then access the dunder name dunder variable on that math module, we bring back math. Okay, so keep this in mind. I'm now going to create a Python file using Visual Studio Code, and I'm going to call this file example_1, and I'm going to save this as a .py file. Inside the file, I'm going to print the value of dunder name dunder is, and then I'm going to put curly braces. I can then use the format method, and inside the format method, I'm going to pass in dunder name dunder, which is that built-in special variable. So very simple so far, a simple print statement which will print back the value that is stored in dunder name dunder. Now when I execute this code directly, in other words, when I go into my Anaconda prompt and type Python and then the name of the file, which is example_1.py, you can see that we then print to the screen the value of dunder name dunder is dunder main dunder. And that's because we're executing the actual file, example_1. Now, if I were to create a second Python file and I call this example_2, and inside the example_2.py file, I simply import example_1 file. You can see that when we go to our Anaconda prompt and type in Python example_2.py, we print to the screen the value of dunder name dunder is example_1. So it prints out the name of the module from where it's been imported. And we saw this in Jupyter Notebook when we accessed the dunder name dunder variable on the math module. So the value of dunder name dunder changes depending on where our Python code is executed. But how can this help a developer? And how does the condition if dunder name dunder is the same as dunder main dunder help us in our Python programs? Well, to explain this concept, we'll create a simple Python program, and we're going to include 3 different functions inside of the example_1 file. So we'll delete the print statement, and then we're going to define a function called task1, and this function will simply print doing task1. We'll then create a function called task2, and we will simply print doing task2, and the third function will be task3, and this will print doing task3. After the definition of these statements, we will then call upon these functions sequentially. So we can call upon task1, then task2, then task3. So when we execute the example_1 Python file, it will execute all three functions. So you can see that when I go to Anaconda prompt and run the example_1.py file, we print doing task1, doing task2, and doing task3. Now let's say that we want to share our code, and another Python program wants to utilize one of the functions in the example_1.py file. How would we go about doing that? Well, let's suppose that the example_2.py file is the second developer who wants to use some functionality from the example_1.py file. Well, firstly, if they were to simply import example_1, and then they were to call upon task1 as a function in isolation, so if they were to put example_1.task1 followed by parentheses, you can see that when we now execute the example_2.py file within our prompt, we first of all print to the screen the execution of example_1 because it's imported and the functions are called instantly, and then we print doing task1, which refers to that function specifically. Now the problem here is that when we import the example_1 module, 3 lines are printed to the screen automatically because of the execution of the 3 functions which sit at the bottom of the example_1.py file. But how can we avoid that? Well, this is where we can check to see if dunder name dunder is equal to dunder main dunder when importing a module. So to prevent all the code running from an imported module that we just saw in the previous example, we can put the execution of task 1, 2, and 3 inside an if statement. So if we go back to example_1.py and now place at the bottom of our code script, if dunder name dunder is equal to the string dunder main dunder, then followed by a colon, then execute task 1, then task 2, then task 3. In other words, if we call this file directly, then please execute these 3 functions in order. So let's just confirm this still works. When I go to the Anaconda prompt and then rerun example_1.py, you can see that we do task 1, then we print do task 2, then we print doing task 3. So the code file still operates as expected. If we now run example_2.py, let's see what we get printed to the screen. Well, this time we only print out doing task 1, and that's the exact behavior we wanted to see. We only wanted to execute task 1, but when we run this previously, it did all tasks first and then executed task 1. So this is a lot better. So to summarize, the dunder name dunder variable is a special variable within Python. When checking the dunder name dunder variable against dunder main dunder in an if statement, it allows us to include code that doesn't get executed if your module is imported by another program. So for example, a common scenario is where someone else wants to use the functions that you've created but doesn't want to automatically execute all of the logic that you've implemented when your application itself is executed directly. When a program includes that if dunder name dunder is the same as dunder main dunder and then executes their program logic, it means that another person can import their module and target specific pieces of functionality that they would like to run. That about does it for this video. Feel free to reach out if you have any questions, and I'll see you in the next video.